Think about this. Every smartphone, satellite, and supercomputer depends on a thin green board hiding billions of microscopic connections. You see one every day, yet almost nobody witnesses the astonishing factory journey hidden beneath its tiny copper pathways. Imagine creating highways for electricity thinner than human hair, with machines working more accurately than expert surgeons. But here's what nobody tells you. One invisible mistake can destroy an entire batch worth hundreds of thousands of dollars. Thousands of chemicals, lasers, robots, and skilled hands must perform perfectly before your phone ever switches on for the first time. Every shining copper line follows an exact path, because even one misplaced micron could stop an entire computer forever. Most people never think about this, but every modern hospital, airplane, and spacecraft depends on these remarkable boards. What happens next surprised even experienced engineers, because the journey begins far away from any electronics factory. Our journey starts in Chile, where some of the world's richest copper mines supply the metal powering billions of circuit boards. Each truck hauls nearly 400 tons of ore, yet less than 1% becomes pure copper metal. The crushed or travels through flotation tanks, where microscopic copper particles separate from ordinary rock using carefully controlled chemical reactions. Next, giant smelters heat concentrated copper above 1,200 degrees Celsius, burning away unwanted impurities in glowing furnaces. After electrorefining, the copper reaches over 99.99% purity, clean enough for precision electronics. But copper alone cannot build a circuit board. Another remarkable material quietly provides incredible strength and electrical insulation. That material begins as silica sand, melted into glowing glass before spinning into incredibly fine fiberglass strands. Those fibers weave into strong cloth, then combine with epoxy resin to create the famous FR four-circuit board foundation. Factories laminate ultra-thin copper foil onto both sides, creating the blank canvas where tomorrow's electronics will finally take shape. And this is where everything changes, because the next machine will carve millions of invisible electrical highways with astonishing precision. The copper-clad panel enters a spotless cleanroom, where even tiny dust particles could ruin thousands of future circuit boards. First, machines coat every panel with light-sensitive photoresist, creating a surface ready for microscopic circuit patterns. Powerful ultraviolet light exposes the hidden design, locking microscopic pathways into the photoresist within only a few seconds. Chemical developers wash away unprotected resist, revealing the exact copper pattern engineers designed months before production even started. Now, powerful etching chemicals dissolve unwanted copper, leaving only the delicate electrical highways behind with astonishing precision. What remains measures just fractions of a millimeter, thinner than many human hairs, yet strong enough to guide powerful electronics. Next comes drilling, where computer-controlled machines spin above 150,000 RPM without missing microscopic targets. Each hole receives a thin copper coating, allowing electricity to travel seamlessly between multiple internal board layers. Hydraulic presses laminate multiple layers together under temperatures near 180 degrees Celsius and tremendous pressure. Green solder mask covers everything except connection points, protecting delicate circuits from moisture, heat corrosion, and accidental electrical shorts. Finally, brilliant white legends print component labels, but one incredible inspection still decides whether every board survives. Now the real test begins, because every finished circuit board must prove it deserves to power tomorrow's technology. AI-powered optical scanners compare every copper trace against digital blueprints, spotting defects smaller than 50 microns in seconds. If even one copper pathway breaks or touches another, the computer instantly rejects the entire board without hesitation. Flying probe testers touch hundreds of points automatically, checking every electrical connection without building expensive custom testing fixtures. For hidden multilayer boards, powerful X-ray systems reveal invisible internal connections without cutting the board apart. Some factories reject fewer than one board out of every 1,000, thanks to astonishing automation and relentless quality standards. But experienced inspectors still notice subtle imperfections that cameras occasionally overlook, proving human judgment remains incredibly valuable. Next comes environmental testing, where finished boards survive intense heat, freezing cold, vibration, humidity, and mechanical stress. Temperatures swing from -40 to 125 degrees Celsius, challenging every microscopic electrical connection inside. Only after passing every inspection can these remarkable boards continue toward assembly inside the world's most advanced electronic devices. But the biggest surprises aren't inside factories. They're hidden in astonishing global numbers that almost nobody ever imagines. Every year, factories produce billions of printed circuit boards, quietly powering nearly every electronic device on Earth. Today's global PCB industry generates well over $90 billion annually, making it one of manufacturing's hidden giants. China leads global production, followed by Taiwan, South Korea, Japan, and the United States, supplying electronics worldwide. Millions of engineers, technicians, miners, chemists, and factory workers help build this invisible foundation of modern technology every day. 50 years ago, circuit boards carried only simple electronics, but today's versions connect billions of microscopic transistors effortlessly. Think about this. Your smartphone contains circuit pathways stretching farther than many people walk in an entire day. Did you know one advanced motherboard can contain more than 10 separate copper layers hidden completely from view? Did you know some aerospace boards survive radiation, extreme vibration, and temperatures impossible for ordinary consumer electronics to endure? Did you know flexible circuit boards can bend thousands of times while continuing to carry electrical signals perfectly? The next decade will bring even smaller, faster, greener circuit boards, transforming artificial intelligence, robotics, medicine, and space exploration forever. And after everything you've seen, one final journey remains before this remarkable story comes full circle. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, where copper, silica, and rare minerals began an extraordinary journey. Shaped by fire, refined through chemistry, and transformed by machines working with breathtaking precision every single second. Perfected by technology and approved only after passing the world's strictest inspections and demanding performance tests. That's not just a product. That's a masterpiece of human engineering built one microscopic connection at a time. Every tiny pathway carries the imagination of scientists, engineers, technicians, and skilled workers from around the world. If you want to go deeper into the hidden world of manufacturing, tell us what product we should explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.